are in listen-only mode.
Good morning, ladies and gentlemen, or good afternoon, depending on where you are. We want to welcome you to this month's presentation of building high-performance VMs with AWS and Azure. I know that a lot of us aren't in the cloud yet, but we're working to get there, and with costs coming down, it's getting to where having something on-premise is going to be less and less. I was one of those anti-cloud people for a long time, but I'm kind of getting on the boat too. So we want to thank Warner Chavez for joining us today. And Warner, I'll turn it over to you now.
And welcome everybody joining us today for our topic of building high-performance VMs in AWS and Azure. And let me get this going here. All right, and allow me to introduce myself. I'm a SQL Server DBA and consultant for going on 10 years by now. I used to work as a level 3 DBA at Hewlett-Packard. I work at Pythian as a Microsoft Data Platform Principal Consultant out of Ottawa, Ontario, Canada. I'm a SQL MCM and a Data Platform MVP. Feel free to follow me on Twitter at Warchaff. If you want to shoot me an email, a lot of people do that sometimes after the presentation. They forget to ask something, they think about it, and after the session, they think of something they wanted to ask. Feel free to shoot me an email there, warner@sqlturbo.com. That's my personal blog. And if you want to check my company's blog as well, just go to pythian.com. We also have a technical blog there that covers not only SQL, it also covers other tech, big data, Oracle, open source, and just data management in general. Right? So the agenda for today, we're going to introduce the main VM models and storage types that you can use to build your SQL Server on both AWS and Azure. And we're going to focus on high-performance configurations, right? So I am going to do more of an overview of not all, because there's some that have nothing to do with SQL Server, right? There's VM models, for example, that are GPU optimized because they're for graphic rendering and things like this. So those we're not going to cover at all. But there's a couple of VM models that we will cover that are not necessarily high performance, but they could be good choices depending on the use case for SQL Server or for some of the other SQL Server related services like SSIS or SSRS or analysis services. And we're going to stay on scope today for AWS. And I don't know if you guys are familiar with the Gartner analysis reports, but just maybe about a week ago, Gartner posted the results of their latest analysis of cloud infrastructure as a service offerings. And Amazon and Microsoft are the only ones in the top right quadrant. That's and Visionaries quadrant. And pretty much the only one that's kind of close is Google, but Google is still a far third. So I'm just going to focus here on the two horses still in the race for now, and that's AWS and Microsoft. So first we're going to cover our virtual machine choices on AWS. Then we're going to cover storage choices on AWS. AWS has a lot more variety and a lot of more moving parts regarding storage, so we're going to go into those in detail. Then we're going to cover VM model choices on Azure. It used to be, when I developed the first version of this presentation, maybe about 16 months ago, it was a lot easier, the VM model in Azure. It was only like 2 or 3 that I would consider decent for high-performance SQL, but nowadays they've added a bunch of new stuff, and we'll go through it. Same with the storage choices on Azure. So the first time that I developed this type of material, we only had the classic storage. So just to give an example, striping was pretty much a must because of the low throughput of regular blob storage volumes. But nowadays with premium storage, it's a must basically. If you're going to build a SQL Server that has to perform in Azure, you got to go with premium storage. So we're going to go into the details for those as well. And finally, we're just going to check some results of a couple of tests I did comparing CPU using a cool little utility called Nova Bench. So I compared a compute optimized machine on AWS with a G series VM on Azure. So we'll look at the results of that. And I'm also going to show you guys an analysis of disk performance that I did for AWS and some of the gotchas or things that you should be looking out for when analyzing storage performance on AWS. Sounds good? All right, and if you guys have any questions, feel free to post it, and we'll have some minutes left there in the end to go through all the questions. All right. So let's talk about first a SQL Server on AWS. So there are several different choices on AWS, but not all of them, like I said, are really built for SQL Server. So there's a couple of general purpose, what they call general purpose instances. And unfortunately, Amazon, well, and kind of Microsoft too as well, their instance model names are not really the most comprehensive thing in the world. So you guys will see it's all like letters and numbers kind of thing. So that's why it's good to have the slides for reference. So general purpose T2, which I'll cover in a separate slide, just because the T2 is not necessarily a high performance model for VM, but it's interesting in how it works in that it's what they call a burst instance. So it gives you a low price and a low base of CPU performance, but it's allowed to burst to higher CPU performance. So that's why I put the star there next to the T2 because it really behaves differently from all the other VM models. Then there's the M4. M4 is the regular non-burst general purpose models in AWS. Then we have what they call compute optimized, that's the C4. So compute optimized usually have CPUs that have a higher clock speed than the regular general purpose or the M4s. Then we have memory optimized, which for high performance SQL servers are some of my favorite ones. These are R3, they're called R3 models. The reason why I like the memory optimized ones is because they usually offer more RAM than the general purpose or the compute optimized. So as SQL Server is very memory hungry and will pretty much eat all the memory that you can give it as long as it has data to fill it up with. So memory optimized, like I said, it's usually a good choice if you can afford to pay for the extra RAM that you get per core. And then finally, there's this model that's called storage optimized. And really, the storage optimized is just a machine that has been tuned by AWS for faster and higher throughput to their storage volumes, and very, very large SSDs that are mounted on the VM. So I could say probably we could find a use case for a storage optimized, maybe for like a data warehouse type of scenario where we build, let's say, a cube off of that VM, and then the processing of the cube is not, happens overnight or something like that, and then we just read off of the cube. I can see that working with a large storage optimized machine, just because, let's say a data warehouse is never going to fit in memory for a memory optimized one. So maybe that's a good choice for that. But like I said, for regular OLTP workloads, I think most people, if they're just building a regular SQL Server, they can get away with using the M4s, the general purpose ones. If they for CPU speed, they could go with a C. But if you're trying to build a high performance one, OLTP, I usually recommend to go with a model that's in the R3 family, the memory optimized ones. Okay. So let's cover just the special case of this T2 instance. And like I said, I just want to cover it because even though it's not for high performance, it is something that might come up. It is something that somebody might about. So it's good to know that it exists. So basically what happens is that a T2 instance runs on a base performance of CPU of about 20% speed of the CPU clock. And as long as you're running below that 20%, you accumulate credits that you can then use to burst. And then those credits, you can spend them by bursting CPU, so meaning going from 20% to 100% CPU off to a max of 30 minutes. So if let's say you have your entire amount of credits filled up, then you would be able to run CPU at 100% for 30 minutes. If you're running something different, like let's say you're running not at 100%, but you're running at 60%, then you will be able to, burst for a little bit longer because, you're not going all the way to 100%. So let's say if you're running at 50%, then you'll be able to keep that up for an hour. So that's the way it works. So it is really not for high performance workloads, but if you do have a workload that is very low activity and then every now and then somebody wants to run a query on a small database and you want to keep it available, then it might be a good choice just to go with a small T2 and just provide that as a very cost-effective alternative. And it's also important to know this because Azure doesn't have any equivalent, so Microsoft hasn't bothered implementing any type of bursting models of virtual machines, so it's a capability that you will only find on AWS. So like I said, it's good to just round out the knowledge for everybody to know that these exist, but they're not necessarily for high performance 24/7 workloads. They're for very kind of like low volume workloads that you do want to provide a decent performance when they actually get used, but they're not for maintained high performance workloads. Okay. So like I said, the biggest choices in my opinion is to do a decision between you want to compute optimize, do you want to memory optimize, or do you want to an I/O optimize, right? So each one caters to a particular strength, and that's where you have to be familiar with your workload. If you're lucky enough that you are migrating, let's say, then you can just run a perfmon trace on your existing VM so that you can characterize your workload and then see which one matches more, if you need the CPU power more, or if you need the RAM more, or if you need, you know, temp DB is a huge thing for you, and you want to have the really fast scratch SSD and, you know, really fast scan rate kind of thing, then you can use the I/O optimized one. So it really depends on workload. In the more difficult situation where you don't really know what workload you're going to get, then I would usually recommend, like I said, if budget allows, to probably the safest choice is to go with the R3s, which have the best cost per gigabyte of RAM, and sometimes just adding a few more gigs of RAM to SQL Server can make all the difference in performance, right? Because more RAM will usually alleviate I/O and will alleviate the CPU spent cycles just reading off of I/O as well, right? So I think that's why I would go with R3. If you don't know exactly the characteristics of your workload, I think that's the safest choice in terms of good SQL Server performance. Okay. Now, there's been another model of VMs on Azure, sorry, not Azure, on AWS that was recently. I haven't seen anybody deploy this in production, but I figured I would put it here in the slide deck since we're talking about high performance. Now, remember, this is a high performance VM. I never said they would be particularly cheap. So this is a new type of VM that Amazon has introduced. It's called X1 Memory Optimized, and really the main reason why they created it is so that they would get certified to run SAP HANA on Amazon. So if for anybody that's not familiar, SAP HANA is like SAP's in-memory database to run the SAP products, and that's why they came up with this massive VM. But nowadays, there is a use case for it, right? If somebody, for example, was doing a big investment in SQL servers in memory OLTP, for example, and didn't want to deploy on premises, well, then they could look into this virtual machine and see if they get, you know, the high performance that they would need. So it's really an edge case. Obviously, most people are not going to need something like this. That comes with 128 virtual cores, comes with 2 terabytes of RAM already, right? So huge amount of SSD scratch space, right? So it comes with a couple of terabytes of SSD scratch space. So definitely not something that you're going to be using for your regular SQL servers, but in the interest of completeness, and definitely mention anything that could be used for high performance. If you had amount of data that you want to move or that you are thinking of putting on in-memory OLTP, for example, or you're going to use in-memory OLTP, and also you're going to use, for example, the new real-time analytics that are available in SQL 2016 with the in-memory column stores, then, suddenly an X1 with 2 terabytes of RAM, who knows, could be a to deploy if you don't want to deploy yourself a big chunk of bare metal on premises. Okay. Now let's talk about the types of storage that AWS offers for SQL. Well, not for SQL Server, but in general for any virtual machine, and how they would apply for SQL Server. And like I said, the choices on AWS are a bit more complicated than what they are in Azure. So there's three main types of storage. So the first one is what they just call general storage, general purpose storage SSD. So this has a lower base of IOPS per gigabyte. So it's only 3 IOPS per gigabyte, and it accumulates credits as long as you deploy a volume that is more than 1 terabyte. And those credits will allow you to burst to 3,000 IOPS for about 30 minutes. Okay, so it works kind of similar to how I mentioned the T2 instances. So it works a little bit similar to that, in that if you're not using those 3,000 IOPS, so you're just at the baseline of the 3 IOPS per gigabyte, then you're going to be accumulating credits. And then if you go to 3,000 IOPS or above that baseline for a certain period of time, then that decreases your credits, right? Since we're talking about 3 IOPS per gigabyte, you guys can do the math. If we have 1 terabyte, which is 1,000 gigabytes, then there's no bursting anymore, right? Because the volume of 1 terabyte or more will always be at a baseline that goes above 3,000 IOPS, right? For example, if you're already using a volume that, let's say it's 600 gigabytes, you could just might as well resize it to be 1 terabyte or more. Let's say you're going to need that space anyway for, in the next 6 months or so. You could just resize it to be 1 terabyte or more right away, and then you don't have to worry about, oh, did my VM is performing crappy on storage because I just used up all of our burst credits, and that's why suddenly I get these messages from latency or SQL servers reporting latency on the DMVs and whatnot, right? So that's a good tip to keep in mind, is that after you cross that 1 terabyte boundary, there is no more burst behavior. You just get that baseline performance of the 3 IOPS per gigabyte, okay? Now, if you do have a higher performance type of workload, especially dependent on really high, always uniform response from storage. So low latency, uniform response. You want the IOs to usually take the same amount of time, and you want that amount of time to be small, less than 5 milliseconds or choice. Provisioned IOPS is the one that's going to give you that same of repeatable performance, and it's by Amazon to quite a bit of numbers as part of their SLA, but it is definitely the most expensive choice, right? So if you want to build definitely the most high performance machine that you can on AWS and your budget is not a concern, then you could go with provisioned IOPS, right? So they have a baseline of 30 IOPS per gigabyte, so it's 10 times the baseline of the general storage SSDs. And on top of that, you can also tweak their IOPS capabilities or IOPS bandwidth independently as well. So you can have a provisioned IOPS volume that is 1 terabyte and try to push, let's say 9,000 IOPS through it, and the system just takes care of it and provides the same level of performance 24/7, right? So for really, really high performance, you're gonna want to use provisioned IOPS SSDs just because it makes the response the same always 24/7, but it is going to be the most expensive choice usually, right? So like with always related to performance, we make a compromise between, price and performance that we want. If we want good performance, then we usually want to have to spend a little bit more. And if you just want the best performance, then for sure you're going to have to go with provisioned IOPS. And the last type of storage is the magnetic. And the magnetic is subdivided in a couple of types I'm just going to cover in the next slide. But for now, it's just, think of your regular magnetic disks. They don't really a latency. They don't really provide a large amount of IOPS, but they're useful. They can be useful for, let's say, a file group that is just an archive. You have a partition table and you want to put some of the older file groups on some slower disks, but keep them mounted to the VM. This could be a good choice. If you have some low priority databases that nobody really queries that much anymore, or if you're just building some VMs for dev or test, obviously not for performance, dev or test, only for functional type of comparisons for dev or test. Just you're just checking functionality for an application, and performance is not the goal. Then yeah, you can put them in magnetic. It'll work. It'll be slow compared to obviously general storage, or even more to provision IOPS, but it's definitely a cost-effective solution. Right? All right, so let's talk about magnetic storage on AWS. So there's two different type of magnetic disks that are provisioned now on AWS. You get the choice when you create the volume. You can have one that is throughput optimized. So these ones will have a larger bandwidth, a pretty decent bandwidth. So they don't have a high number of IOPS, even though the volume can be fairly big. I believe it's up to like 4 terabytes or so. It will only go up to 500 IOPS, but it has a decent bandwidth of 500 megs, right? So for things like I mentioned, let's say an archiving file group that only gets a report that does like a large scans every now and then, or if you want to have your locally to the VM in case you need them really fast, and then from there you move them to S3, for example, that could be another good choice. If you really, really just want the bottom of the barrel to keep lights on type of thing, then you can go with what they call cold magnetic storage. It's literally the lowest storage that you find and that you can attach to the VM. And that will be my recommendation, is just to use that for functional dev test only, since yeah, it doesn't provide any type of latency SLAs or anything like that. It's just they'll give you some storage, and they don't provide any guarantees of how well it will perform or not. So. That's choices on AWS. So again, when you're building your virtual machine, you have to think about what the volume's purpose is going to be. If you are building for high performance, then you basically just have a choice between a general purpose SSD or a provision IOPS SSD volume. And again, provision IOPS is going to be the most expensive option, but it'll give you a higher baseline, and it will not fluctuate during the day, right? So there's no burst behavior on that one. Now, something to keep in mind, this is something that has we have found in our clients that comes back to bite people all the time, is that each instance of a VM in AWS, depending on the model, it has a different bandwidth limit of how much it can push, because it's all in the end, it's all like network attached storage. So they all have a limit of how much data they can push to and from their storage, right? So this limit is usually what I find to be the first bottleneck that people will hit once they're using their storage. Because what can happen is that you can go in and let's say provision this massive, let's say a magnetic throughput optimized volume that you think is going to give you 500 megabytes per second. But then when you look into the actual specifications of the VMs on AWS, it turns out that the VM that you picked only had, let's say, a 200 megs per second bandwidth limit. So you're going to hit that bandwidth limit way faster than the time you hit your 500 megs volume limit, right? So there's something different there. There's one thing is the limit of how much bandwidth the VM can push, and the other thing is the limit of the bandwidth that the volume can take. And the bandwidth limit of the VM is always going to be the first one that you might hit before you possibly hit the limit of the volume. So I don't know if you guys can see there because it's kind of small. I basically copied this table off of the AWS documentation, but let me see if I can zoom into it.
Yeah,
Okay,
zoom it because it is a little small. There you go.
better? All right. So if you guys just take a look there, for example, let's say we have a D2 4x large. So let's just focus on this one right here. So D2 4x large, it has a dedicated EBS throughput, so that's the connection to the elastic block storage where the virtual disks are basically in AWS. So that's 2,000 megabits per second, which translates roughly to about a max of 16,000 16K IOPS. And using that same 16K IOP measurement, we get to about a max of 250 megabytes per second. So that's a really good example, right? So we could say for, let's say somebody deployed a couple of general purpose SSD volumes that they thought should give them 300 or 400 megabytes per second of bandwidth. Well, because the D2.4x large has a bandwidth limit of 250 megs, they're first going to hit that bandwidth limit before they hit the other limit of their storage. And if you're just over provision your storage that way, in a way that you're hitting the 16,000 IOPS or you're hitting the 250 max bandwidth limit before you're even hitting the limits on your storage, then you're basically just giving away money to AWS, right? Because you provision something that you're never going to be able to use to its maximum capacity, okay? All right, so some other tips, like I said, the tip before about the general purpose volumes, that once you make them over 1 terabyte, they they don't even have burst capabilities. They'll just have a higher baseline permanently. So in general, the larger GP volumes, they can burst longer. So like I said, if you are thinking or very close to going from 600 to 1 terabyte, then you might as well just make it 1 terabyte, for example. Last I checked, the C4 8 extra large or the D2 8 extra large, these VM models offer 10 gig interfaces exclusively for network traffic. So this is, again, this is for a very specific use case where the usual network interface, you really believe that you need a 10 gig one because of the amount of data that you're pushing in or out through the network interface on the machine. And the other thing that is mentioned is if you are restoring any volumes from snapshots that you created, is that you should pre-warm them. Penalty there because they snapshots are usually stored in S3 storage by Amazon, and so there's a penalty if you first read it. It moves those blocks from S3 to the EBS. So if you pre-warm them, there's a command. I forget right now what it is. It's on the AWS documentation, but there's a command where you can just run a command line that'll read any file. It'll just read it and discard whatever it's reading and just leave the file there on the disk. And that just basically forces everything to be read from S3 to the EBS volume before, let's say, you open the server up for users to actually use your restored snapshot volume. All right, so let's move over now to the other side of the house, and basically we're going to talk about Azure. VM choices in Azure. So we're going to focus here on the ones, again, that are make sense for SQL Server. There are some other ones that don't make sense. Like I mentioned, the graphic performance unit optimized ones, the GPU optimized ones. So the first generation, the very first one on Azure, what's called the A series. This generation of the A series machines has been more than surpassed at this point. So if you do have a SQL Server that you had already deployed on Azure and you had it on an A-series machine, I definitely recommend that you look into just doing a cutover or a shutdown, reallocate, turn back on move for your virtual machine to move to a newer series. So uh, the best ones for high performance are either the D series or the G series, and they're both an evolution from the A series. The D series performs better than the A series. The G series is usually more expensive but better, beefier specs than the D series. Now there's also an F series. The F series could be a good general purpose SQL Server, but it's not necessarily best performing one. So the reason for that, provides fast CPU, but it doesn't provide as much RAM as the D series or the G series. Okay. Now, when you see just the letter by itself, they're like A, D, G, or F. That's the base model. And then when you add the S on it, then that's when they mean that they are capable of doing premium storage. So then we see there DS, DSV2, FS, GS. All these provide premium storage. There's never bursting capabilities on Azure VMs either, so you always get the same baseline performance. Obviously, you don't get any savings if you did have a workload that could adapt to that, but at least it's easier to pick, right? For high performance SQL servers, there's really not a lot of choice. You should go premium storage, period. I haven't found, if you really want to build something that is high performance, there's no point in building it with classic blob storage because if you wanted to get something close to the level of premium storage, then you have to be adding multiple different volumes and you would have to stripe them with something like storage spaces and so on. The complexity itself is just not worth the hassle now that we have premium storage available. Now, if you see here, there's not only the D. Let me go back here. So there's not only the D, but there's also this DSV2. So DSV2, they have same type of model as the DS machines in terms of the cores and the amount of RAM, but the V2 comes from having a increased clock speed for CPU. So if you have a DS machine currently in production right now, it might not be good enough or a good incentive enough for you to move to a DS V2. But if you are deploying a new SQL Server in production in the near future and you want it to be a high performing one, then you should look to deploy a DS V2s instead of just DSs. Okay? Okay, so what do I recommend to pick between those choices? So the DSV2 I think has a good balanced config. It has the fastest CPU, like I said, and a good amount of RAM. And the cost of the DSV2s nowadays is pretty much the same or even less than DS machines depending on the region. So imagine in some regions you could be paying more for a machine that has the same amount of RAM but slower CPUs. So obviously, the reason why that is because they don't want you to deploy those. They want you to just go to DSV2s, but they can't just retire all the DS that people already have deployed, right? So like I said, recommend DSV2 for many high-performance workloads. This will be good enough. We have customers that have deployed DS machines to run, for example, Dynamics, the ERP from Microsoft, with good results, run availability groups. If you need to go further than what the DSV2s can offer, then you can go top of the line with the GS. So the GS has even faster CPUs, and it also has even more RAM per core. Obviously, that comes at a cost. I'll show you guys the portal real soon, so we can just look at the prices difference and compare. Unless you're CPU bound, or if you can fit your database in RAM, let's say if you get a large GS and suddenly you can fit your entire database in RAM and that gives you a really huge boost in performance, I usually recommend most people by default to deploy on some sort of DS V2 machine. If justified, if you do find that you are bottlenecked by CPU, or that you do want to have extra RAM per core, then you could change it to a GS at that point. But like I said, I've found that large DS machines can handle pretty decent high performance workloads. Um, the other type of instance that might be worth considering for SQL Server, it might not be the best for high performance, but there's definitely some use cases for it, is the FS. So the FS, like I said, has CPUs that are just as fast as the ones on a DS V2, but they don't provide as much RAM. So they're more for like batch style workloads, something that maybe you just run some processing overnight on the SQL Server, and then yeah, let's say you're doing like an SSIS pool of some data, you transform it, then you generate some files that are consumed by somebody else. That type of workload I think could work well on FS because it might not need as much RAM, or if it does use up all the RAM, it's not going to be an interactive high performance workload where there's thousands of users waiting for it, right? So for that type of scenario, I could see an FS working well, and the FS would be cheaper, both cheaper than the GS definitely, and both cheaper than a DS V2 as well. Okay. All right, so let's go into the storage choices for SQL Server on Azure. First one is the classic storage of basically the same beginning blob storage. First time that Azure introduced infrastructure as a service VMs, this is the storage they offered. So you could create page blob storage, and each volume provides 500 IOPS and about 60 megabytes per second. Now, there's also the temporary scratch local SSDs, similar to the ones that Amazon provides for their VMs. Now, these are ephemeral, right? So if you restart your SQL Server VM, whatever contents were on that SSD will just disappear. So it's only good for temporary type of workloads, but if you're TempDB, definitely you should put it there. It has local caching, it's attached to the VM, so it's really fast for TempDB. If you are using buffer pool extensions, for example, this was the feature introduced in SQL 2014 to extend the buffer pool. You could use that temporary scratch space as well because the buffer pool extension file will get cleared up during a restart anyway. Okay. Now, if we are going to be doing high performance, like I said, I recommend looking into Azure Premium Storage. And this is available in three models. So there's P10, P20, and P30, and they have different sizes. One big difference here on the way that the sizes are built is that the premium storage, you pay for the full volume size, regardless if you use it or not. So I had prices there from last year. So let's say a P30 that's 1 terabyte was 120, almost 123 US dollars. Even if I'm only using 1 gigabyte out of that 1 terabyte, I'm still paying 123 US dollars. Okay, there's no way. Whereas Azure Page Blob Storage, if you deploy a volume that is 1 terabyte, but you're only using 1 gigabyte of it, you only pay for 1 gigabyte. So Page Blob Storage, because of this, it still has a place. So basically where I would use magnetic on AWS is where I would just use regular Page Blob Storage on Azure. So old archive type of storage, dev test machines, low throughput file group requirements, all that kind of stuff. I can put it on Page Blob Storage. I know it's going to have lower IOPS, lower bandwidth, but it's still going to be available. So if we look at the premium types, now let's zoom in a little bit here. So if we look at P10, for example, it has the same base IOPS as a Page Blob Storage, so it has 500, but it's a boost in bandwidth. It has 100 megabytes per second as opposed to 60 megs or so provided by regular blob storage volume. And then after that, P20 or P30, they go way above that. Obviously, P20 is 2300 IOPS, 5000 IOPS for P30, and then 150 megs to 200 megs per second of bandwidth for a P30. If necessary, you can also stripe these through Windows storage spaces, for example. If you want to put one data file that is spread among let's say two P20 volumes, then you could create a storage space with two P20 volumes and then create the data file there. That works just fine. But same as AWS, you have to watch out for the bandwidth. So, like I mentioned on AWS, the same gotcha can get you on Azure. People deploy storage that sometimes goes above the bandwidth capabilities or of their VMs, and they're basically just giving away money for free to Microsoft. So another reason why for high performance you only want to deploy on the star S machine, so DS, GS, or FS, is because IOPS and storage bandwidth are published only for the star S machines. So on a D1 machine, they don't publish IO, IOPS, or megabytes per second limits per volumes, but they do publish them for the DS1 machine, right? So here I took from the documentation the different limits of the DS1 machine. So as we can see, the DS1 limit is 32 megs per second. So if I go back and I deploy a P20 premium storage volume that can supposedly go to 150 megabytes per second, it's not going to hit that limit ever, right? So I'm just basically giving away money for free there. If I go all the way up, I can go all the way up to a DS14, that's 50,000 IOPS and half a gig of storage bandwidth. So a very, very decent, could be very high performant type of VM, right? And there's different, like I said, these values are published as well, not just for the DS, but they're published as well for GS and FS. And actually, I have the link here on the slide deck. I'll send it to Tom at the end of the session, and Tom can share it with the chapter. Here's the reference of the documentation page where you can find all these different sizes. I just want to show it to you guys real quick. So, here's the official doc, and I'm going to zoom in a little bit. So if you look here on the right hand side, you'll see it has all the different type of models, and you'll see it has that the DS, the DSV2, the FS, and the GS. So let me just go to one of them. Let's say we're going to analyze the DSV2 ones, because I am picking sizes. So let me zoom in again. So we can see here in the documentation that the DSV2, it has a 3200 IOPS and 48 megs per second that it can do, right? I can go and check, let's see, let's take a look. The highest DS that exists now is this one. So we can see that DS15, for example, that one is 64,000 IOPS, and it's almost a gigabyte of full storage per second. So really, you can definitely build some really high performance stuff there. Now, on top of that, we also have the GS. So let me go to the GS just to show you guys the, the Formula One type of VMs here. We'll go all the way here to the bottom, and then you can see here the GS5. This is the highest one that you can provision right now on Azure, and this is 80,000 IOPS and 2 gigs per second. I've had some clients that could probably not fit in that machine, but they are few. The vast majority of them would definitely be over provisioned on a machine like that. Obviously, the cost of that machine is quite significant. All right, so this is how you find all those little values of limits of specification that you can use when you are designing your VM. Okay. Oh, and something else, if you do go on the portal, I just wanted to point it out here in the slide deck because a lot of people don't notice, but the F series is the latest one of models of VMs that they introduced in Azure, and it has a new standard or naming convention. So starting with the F series, and this is the way they're going to be named going forward in the future. So the numeric value after the family name matches the number of CPU cores. And then after that, if there's anything different that differentiates the VM, such as, like they said, the premium storage, they will be designated by letters, in this case, the S, right? So if you look at the portal, let me show you again real quick. So here's the portal, and we'll see the difference here in the naming convention of what they've been using and then going forward. Let me just zoom in here. So you guys can see, for example, the GS, it says GS1, but it's a 2-core machine. GS2, it's actually a 4-core machine, right? If we go back and we look at the F, and this is how they're going to be named going forward, so that's why I wanted to point it out, because it's going to be a lot easier for everybody here at a glance to know what we're talking about. We're starting with this, the Fs, it's a F2S, so it's a 2-core machine. The F4S, it's a 4-core machine, right? It makes a lot more sense. And we know because of the S that it's a premium disk machine, right? So that should make a lot more sense. Now, if we look into what I was saying about the price, obviously machines such as the GS5, which can push 80,000 IOPS and 2 gigs of bandwidth, that's, you know, it's Canadian dollars, it's more than 7,000 monthly to run that VM, right? And then the other thing that I wanted to point out that I was talking to you guys earlier is, for example, if you check the DS14, look at the price, it's 1254 Canadian. And if we go back up and we see the DS14 V2, it's actually 1203 Canadian. So it's about $50 less per month to deploy the V2 option, which has the exact same configuration, but it has faster CPU. So just, you know, if you're designing this, or you know that somebody in your organization right now is looking at this and they're actually made the mistake of planning for a DS instead of a DS, you know, stop them while you can, because it's not a good deal. You want to go with the V2 machines nowadays. Okay. All right. Some other tips here. Some published best practices from Microsoft for data disks is, if you're deploying page blob disks, don't put any caching. If you're deploying premium storage disk, only enable the read-only cache. They found that's the best performance that you get for both types of disks. And if you are striping with storage spaces, for example, you can stripe 64 KB for LTP according to the best practices, and 256 for if you're deploying for a data warehouse type of workload. Okay, now I'll show you guys real quick the CPU test. So this was a comparison. Oh, sorry, we're back. This was a comparison between a C4, the Amazon machine, a DS, and a G series VM. And just very quick, obviously, the results here. If you guys can see here, DS slower than C4. The red is integer operations per second, but the G is definitely the fastest one. The G is fastest actually in all the categories compared to compute optimized on Amazon, and obviously the DS, which we would expect because we know that the Gs are more expensive than the Ds on Azure, but it's also good to know the G is definitely even faster CPU clock-wise than the compute optimized ones on AWS. So that was the CPU comparison I did. Like I said, I run this with a utility called NovaBench. For disk I/O analysis, let me show you guys what I did there. So this is a disk analysis I did for a client that is running on AWS. I use PAL, so if you guys are familiar with the performance analysis logs, I actually did a session on PAL just a couple of weeks ago in another chapter. But so first, this here we could see definitely that there were some high latency values. You know, 164 max, a full half a second latency on one volume, for example. On write, we could see the same, like some volumes, for example, had a really high average of 67 milliseconds average volume. So we could tell, like, you know, there's definitely something going on here, guys. If we see here, for an i2 extra large machine, both the D and the E are going over what is the expected value, right? So if I go to Amazon's documentation, here I copied it to the Excel sheet so we would have it as a reference. This is what the client was running, right? So it's got a expected throughput of 62.5, and a maximum IOPS per instance of 4,000, as long as you're doing 16K IOs, right? Which SQL Server might not necessarily be doing. Like the IO size that SQL Server will use fluctuates wildly depending on the type of operation that's going on. But as long as you're getting close to those numbers, that gives you an indication that, yeah, something might be going on, right? So by running the perfmon trace on the bandwidth consumed by the disks, we can see that, let's say here, it was 62.5, the expected throughput. Then if we go back here, we can see this one is really close already, this value right here. And then these two values are already over the documented value that we have for that particular model instance in AWS. Now, if we look at the IOPS, we go into the same thing, right? We know that these were all general purpose SSD volumes, as you guys can see. And remember, we talked about that they had these were 500 gigs, so they were subjected to the 3,000 IOPS burst capabilities. And as we can see, they all max out at 3,000. So we know that they are pretty much just hitting the roof of their capability at some points, right? Now, and if we went and looked into the latency reported by SQL Server, we did find that SQL Server also reported high average write latency on D. This is information that I got from the DMVs. Once we went to the DMVs, for example, this was the virtual file IO stats DMVs. It basically just corroborated the other info, and we could see that, especially writing, it was extremely slow for many of the databases. Obviously, this an instance that has many different databases, right? And that's pretty much it. The key here, like I said, is to check the documentation against what you're seeing on both IOPS, right? So as you're seeing here, the amounts that you capture for IOPS and the amounts that you capture for bandwidths, and see how they match up to the documentation. And if you're getting close to these limits that are published by Amazon, and then it's not an issue of just, oh, let's add another volume. Well, it's not just that you need to add another volume, it's that you're also hitting the limits of your model of virtual machine as well. Okay, so that's critical, definitely, to getting good performance on both AWS and Azure. All right, so recap for AWS. So there's T2 instances. That's a good price performance balance if you have a workload that is not really 24/7 and can just be quiet most of the day and then burst during small amounts of time, but it's not really for high performance workloads. Just want to mention that for completeness. I usually recommend to go between compute, memory, or storage optimized, depending on your workload characteristics. If you don't know your workload characteristics, I usually just recommend to go with memory optimized to play it safe. Make sure it's EBS optimized for optimal I/O, though most of the new models of VMs are EBS optimized. If it is truly 24/7 high performance, provision IOPS SSD will be the best option. It will be the most expensive though, so too bad. Make sure you have enough bandwidth, just like I mentioned before, and you can definitely use that local SSD for 10 as well, or for BPE, just like you could do that for Azure too. So recap for Azure, we have the A-series instances. Those are the first generation ones. You should definitely not use those anymore. Their specs have been surpassed by the D and G series VMs. If you are going to be used, the Ds, definitely go with a DS-V2. Like I said there, for high performance, the pick is really between DS-V2 or GS. Though, as we mentioned, the FS might have a use case, but it's not necessarily a high performance use case, right? For premium storage, definitely deploy on premium storage, first of all, if you're going to be using if it's targeting a high performance machine, and make sure that your VM has enough bandwidth. Very similar analysis that I showed you guys for AWS. You can do the exact same analysis on Azure. Nothing changes from that front. Just compare what you're getting, or the type of performance that you're currently getting to the documentation limits for the VM. If you are using older blob storage, unless you really use it for something that is very low SLA in terms of performance, you're most likely going to need striping to go over this lower limits of blob storage. And make sure you have enough bandwidth in general for the VM, and use the local SSD again for TempDB. And I forgot to put there, but BP, yeah, as well. Like I mentioned in the slide before, BP is always also a good choice to put on that local scratch space, just because it will get nuked regardless if you restart SQL Server. Okay. All right, and that is the material for today, and it looks like we doing pretty good on time. Tom, I don't know if we have some questions.
We've got one so far, Warner, and I'll go ahead and read it to you here. You talked about primarily about using Azure VM disks for your SQL database, but isn't there a 16 disk per VM limit? Wouldn't there be more of a performance benefit to use SQL 2014's data files and Azure Blob functionality since, as I understand, it has theoretically a maximum of 32,767 blobs, each at 500 IOPS. Strapping the SQL data files across these is obviously easy to do.
Yeah, so I've had a couple of people that tested those data files directly to blob storage, and it was pretty similar to just deploying them on the disks. I mean, if you do have that super large amount of data files, you could probably do that. You're still going to be using the bandwidth of your machine, so the bandwidth of the machine is still going to be, you know, the main number one thing. Also keep in mind of, for example, during recovery, SQL Server needs to go out and read each data file. So it might actually affect other things, not just online, querying back and forth. But let's say if I have, 1,000 data files over out in blob storage, that will have a higher cost. Just stayed with 20 data files and put them in different premium storage volumes. So it really depends on what you're trying to do, but I just found that for most cases it was a bit of a hassle to deploy to the blob storage just for the performance that they were getting regardless. Um, Again, I mean, if it's something that you think is cost effective for you and it works for you, then that's fine, but it's not my default go-to strategy for a high performance machine in terms of manageability and just, general architecture.
All right. And any other questions, guys, go ahead and put them up. Warner, thank you again for presenting today to the past virtualization chapter. For those guys that have not signed up yet for the past summit in October, Warner and I will be there. We'd love to meet you, and you can go to the virtualization.sqlpass.org website, and there is a code up there, and you can get $150 off the registration fee. So please go ahead and sign up and come see us. We'd love to have you out there. It is a great time out there, lots learned and a lot of partying. So depending on how much of a night owl you are, will depend upon what you do. So looks like we have no more questions today. So once again, thank you. Next month we'll be having Brent Ozar on, getting that posted here in the next few days. And we'll talk to you again next month. Have a great day. Goodbye.
Thanks, everybody. Bye.